Okay, picking up again from last time, where we created a basic controller, so we can now move around in 3D space, but we don't fall off, and we can't jump, we can't crouch, but it's a good start. So what we want to do now is actually step it up a bit and kind of work how things are going to interact with each other before we kind of work out the other stuff. And that's because we want to make sure things stay organized and not create a bunch of one-off situations that we're going to have to solve later. So basics of it are, we now have a player. This player we don't want to create on every map, because where we are, where we start, our stats and such might change from time to time. So what we want to do is actually straight away turn that player into prefab. And our prefabs are something that's common on many engines, but they might be called something else. For example, on Godot, they're just called scenes. So you load a scene into a scene, and your scene might be a node tree. Weird naming, but your player is a scene in Godot. In Unreal, it's a pawn, I think, or a character or something. So naming might be different between each, but it's as simple as creating a folder for it and just dragging it in. So now if you've got your player, you delete your player, you can drag in a new one, and you've got a player again. And that's essentially what you do when you spawn something in. You're grabbing a true copy and then pushing that in. Now that gives you the advantage of being able to oh hey, there's the collider. Cool. By giving you the advantage of being able to kind of pop into the prefab view, which gives you a lot of detail on the prefab itself. So now that we're here, let's start the timer so that we try to stick to doing this in an hour and not run too long. I tend to have a tendency, if you give me time, I'll use it up. All right. Okay. So a few things I was thinking about last time is that your position really should be at 0. You really should be starting, kind of having your origin on the ground, not up. Makes a lot of things so much simpler. Which means that your collider is now in the wrong place. We want to move that up. So we've got a height of 2 on our collider. So we want to move it up on the y-axis, up by 2, 1/2, half its length. Now you'll notice it's still under. That's because 2 is actually too long. 2 is this part, and then it's got a half sphere on top of it. So we know that our radius is 0.5, meaning we can just cut this down to 2 minus 0.5/2 times 2. So be 1.5. And that should be... Is it? Height 1. Maybe I got something else wrong. Center 1. Oh, yeah. Okay, so it's 2. So 1, not 1/2, but 2/1. 2/2. Okay, so never mind, forget all that. In Unity, it takes the radius into consideration, so this is actually only 1. So it's 0.5, 1, 0.5. And then we can readjust this up from where it was to 1.7 probably. Yeah, looks about right. And then back into the scene should give us a player that you can kind of stick on the ground. So Y0. And when you hit play, it should be the right place. Yep. Looks good. All right, so now we want to kind of look at this properly and say, okay, you've got a player, we've placed the player in. That's not actually how things work in a real game. Rather, what we want to put in is a spawner. So let's say you start the game up, you're in the main menu, you hit new game. Once you hit new game, you want to start the new game, spawn your character in the correct place with kind of the starter stats, basic weapons or whatever. And that typically, like in an Unreal, would be called the game mode. Probably more often it's called a game controller. So we can actually create that as an object. It's not always the best idea to do that. In some situations you wanna, if you're really like developing a full game, you want these things to auto load in so that the scene doesn't need you to create a game controller every time. But this being a prototype, I think we're okay. Now that brings us to kind of a Unity concept that is kind of important, which is called a scriptable object. So a scriptable object, unlike a game object, doesn't actually exist in the world. It's kind of a piece of code that exists without it being a physical object in the world. And it's, again, not unique to Unity. A lot of engines have this, but they're called different things. And in Unity, they're called scriptable objects. So the nice thing about it is that whenever you use it the first time or you need it the first time, it'll load it in. And then that one object can be shared between different, kind of components and game objects and such. And it's a really good way to get messages across from one object to the other. Now, why is that important? Because when the game starts, we want to have spawner objects, and we want to know that the game has started. And once that happens, all spawners spawn what you need to spawn. So, and then also kind of which spawner to use and such. So it's kind of something that ties everything together. And the way I typically do it is the game controller doesn't actually have any knowledge, any kind of logic in there or knowledge or anything. The only thing it knows is that it loads. Basically, all it does is loads the initial kind of game scriptable object. So what we'll do is just actually create a new script. Now, it'll be a bit complicated if we just kind of throw everything in one folder. So we'll do kind of a behaviors, and then we'll do one that says player behaviors. We can throw player movement in there. Just keeps it a bit organized, and then we can lagged a bit there. Add one that says scriptable objects, and we can throw game scriptable objects. Keep everything nice and organized. So I'll open it up, make things bigger, so people like Nick can see things. And we are gonna call this, it's not gonna be a mono behavior, it's gonna be a scriptable object. And as well, there's a tag, which I don't remember. It's something I always have to look up. Yeah, so there's a tag called, or a property called create asset menu. File name equals game, menu name equals say data slash game, and we're going to order this as 1. So what that does is it allows us to actually create one in. So the difference between a behavior is that it's a component that's attached to a game object, whereas a scriptable object exists in the project view or in memory or whatever. So now that we've created a game scriptable object, what we can do is we can go ahead and create a folder called, let's call that folder data, and in data we're gonna just create a game scriptable object, and that is an object that just is, it exists. It's not loaded until the first time you load it. So the way you do that is you can just add another behavior section folder called controllers, and we'll create a game controller script. Oops, what did I do? Create new script. And in there, we are gonna just have a public game. So once we attach a game controller to here, we can grab that game data, just drop it in here, and probably create a controller section here as well, and just prefab the whole thing. So now that game controller's job is to load up the game data, which is a blank at the moment. Okay, blank. So what do we do with it? 2 things. First, we should probably have a initialize method, and we should probably also have an update method. Now, game objects don't update like components do, like mono behaviors. They don't automatically update, and that's by design, because they don't exist physically in the world. But in this case, what we want to do is actually just call update on every game controller update, and that's going to be its job. It's just gonna get the game initialized when it starts, and then make sure the game updates, and that's it. So what is game gonna do? Well, simple things like, for now, just keep it simple. We wanna, on initialize, get a list of all player spawns, and then just probably take the first one and get it to spawn something. Obviously this isn't actual code, but just to note, that's what we want to do. So next step, we've got a game controller, it's calling game, it's calling initialize, we know what we want to do. For this to work, we're going to need an object in the scene that handles spawning of the player. So what we can do is just add a spawners kind of section in here. And we will need a behavior. We can add another thing called object behaviors. Oof. What is going on? Okay, object behaviors, and I will add a player spawner, which is not the same as a spawner, which spawns probably game things. So player spawner doesn't need any of these. It will just have a spawn method, and probably would need a reference to the player prefab, because that's what's going to be spawning. And kind of Unity specific knowledge here. We've got the player prefab. Let's create a an empty. We have two players now. I know why, because I duplicated the whole tree. Whoops. Player start spawn. That. And we're gonna add the player spawner component to it. So that needs to know the prefab. We've got the prefab here, entity player, grab that in there. This whole thing can be prefabbed. What that does is it allows you to have multiple, and probably at some point have a priority or something, or naming at least. But for now, we're just gonna assume there's only one. It's at 0, 0, 0. We can go ahead and delete the player. And one more thing, just for organization, we could probably as well add the transform of the entity's root object. Which is this guy. And that's just for organizational sake. And got that. So going back to the game, when we start, we want to get a list of all player spawns. So we can do there is get Unity game object dot find objects of type player spawner. That is a very expensive call. But since we're only doing it once and initialize, who cares? Then we're gonna say if the length of player spawns, so that means how many player spawns we found, is equal to 0, we just want to return. We don't want to do anything. And then if not, we are gonna grab the first player spawn and spawn. Back to here. We've got a player prefab assigned, entities root object assigned. Speaking of, just make sure this is 0, 0, 0. Yeah. What do we do with that? How do we spawn something? We're just gonna initialize. Is it game object dot instantiate? And we're gonna instantiate player prefab, so a copy of player prefab, and we're gonna place it under entity's root object. And at the position, before that, so add position of this. So grab our transform, our current position and our current rotation. Cool. So now in theory, when we hit play, it should create a player under this. Yep, player clone, that's us. It works. Cool. So why did we do it that way? We want to link things up as we are spawning them in. So when they spawn in, we want to link up all the different kind of components. And we can show that by, I can show that very easily by taking, but basically showing you now that we've got a game controller and we're spawning in something, that means if we die, we've got a way to respawn, right? But how do we know that we died? Well, that's what another game, a scriptable object would do. So let's say players are, so that's the player, you've got player movement. We want to add to player movement or another behavior to our player. That behavior is health. Actually, health is not even exclusive to players. Almost everything has health. So we can actually go ahead and create another folder and just say entity behaviors. And just because I like to keep things organized, we can player as a type of entity, so we can just drop that whole thing into entity behaviors. Losing my voice, man, today. It's very cold. My voice isn't doing great. Health. So what does health do? Well, health keeps track of your health. Simple as that, you know, kind of health. We also need to know what is the maximum health that we can have. And then we'll have a couple of we probably need the start function. So when we start, we want to set health to max health. So everything spawns at max health. In fact, what we can do is give ourselves kind of a default max health that isn't 0. So let's say 10. And then we want to give ourselves a couple of methods as well. So we can damage and amount. And what that does is we will reduce that whatever damage amount from health, heal, and in fact what we can do is we don't want to do negative damage and we don't want to do negative healing, so we can just gate the whole thing. If amount is less than 0, amount equals 0. Same here. If amount less than 0, amount equals 0. Additionally, if we heal ourselves to more than max health, health is greater than max health, we want to set health to max health. If health is less than 0, well, less than or equal to 0, then health equals to 0, and we have died. And if we have died, we do stuff. Now, for debug purposes, I'm just going to put the update function, update method back in. Typically, health is not something that's going to check every frame. But in this case, we want to check if input dot get key down, key code D. Oh, D is a silly one. Let's do H. Then we want to take 10 damage, which in effect in this case will kill us. Well, 100 damage, just to be dramatic, and show that everything works. So we now have a way to kill ourselves. What do we want to do when we die? Two things, really. In this case, I mean, normally you would have a death animation and then do all that stuff. In this case, we're just gonna straight up destroy ourselves. So we're gonna destroy the player game object. And then as soon as we do that, we're gonna notify, we wanna notify the game that we have died. And how do we do that? Simple. We can give ourselves a reference to game, and when we die, when we or whoever dies, we want to let the game know that that happened. And how do we do that? We can create a system where we can send arbitrary messages to game, or we can actually define what those are. So in a very big game, we can just give ourselves tons of flexibility by just doing that. So actually it's a good idea to do that. Let's see how that's done. So we've got game, we've got our initialize, we've got our updates, which is empty at the moment. Let's also add an event system. Game is not going to be the only thing that has it. So rather than do that in game, why don't we add a new type, create a new class called Scriptable Object with events. And what we'll do is open that up. Instead of game inheriting from scriptable objects, we can inherit from scriptable objects with events. So now most of our kind of system type scriptable objects will have events, which is something that we can define here. So how do events work? We're gonna have a listener, so something can listen to the event, and something can invoke, or I guess, what's the word? Send an event. Send is probably, invoke or send are the two kind of big words people use for those. So how do we do that? We are going to create have a list of events, which is actually a dictionary. So private dictionary something. We're gonna that's gonna be an event definition. You can add that here. Scriptable object event, and a scriptable object event is going to have a event key and event name, right? Say a key, let's just call it a key, and then kind of an array of parameters. Yeah, and therefore we can kind of organize those as a string, basically as string keys, and then scriptable objects list. Is it? Give me a sec. Let me think about this. No, we're gonna have a list of I don't know if I like to do it this way. Would I like to do it this way? No. Let's rethink this. Rather than creating a new object and all that and complicating our lives with a whole like event class, we are gonna have kind of two methods. Sometimes it's easier to start with the methods and figure out how you want things to link up before you kind of build out the data structures. But you wanna listen, and you wanna invoke. And when you're listening, you are listening to a key, right? To an event key, event name, let's call it, rather than using the word key, event name. And you're gonna invoke, or it's going to invoke a an action which has a parameter of object array. Excuse me. And it's gonna be callback. Yep. So system.action object. Need to call it something, don't we? Listeners. Just initialize that as soon as the scriptable object comes up. So listen. Unlisten. So I mean, let's give it better names. Add listener. Remove listener. And invoke event name and then object array parameters. And that would basically just get the oh, I mean, this is a list actually. Oh, this is going to be long, but a list of actions. And if listeners dot contains try get value contains key. Oh, try get value. Yeah, try get value of the key, which is event name. Oops, event name out list system.action object array. We're going to call that action. Then what we want to do is take that action or actions actions.count, and we're going to try taking that action and invoking oh, sorry, actions I dot invoke that action with parameters. So maybe a bit confusing or complicated, but I will go through it a bit more, a bit more in detail. Oh, catch. We're just gonna, if there's an error, we're just gonna spit it out. Yep. Okay. If reason why we do that is we don't want to break stuff. Well, we can throw actually. Throw will work here. So we just want to throw that same error. What happens is if we don't handle the error here, and this is looping and looping and looping, and then, it has a list of actions. One of them throws an error, it's not going to invoke the rest. So we want to just handle that error locally and throw it away. Let's just do that. Yeah, I think that'll work better. I think even if you just throw it, it'll still stop things. Because it just goes up the tree and then kills itself somewhere up there. So what we want to do is when we want to add a listener, we're going to check if listeners contains the key that the event name, and if it does, we are gonna add the action. Yep, to the list, and otherwise we're gonna add that key, the event name key. New list system.action object. Ooh, confusing to type out. And fill that with the callback. That doesn't work. That's fine. We don't actually need to populate it right now. Let's just do that. Get that listener created and the list created, and then since now it's created, we can just add it. So actually, simplify things just so we're not repeating ourselves. We can add it either way, but if it doesn't contain it, then we'll add a new list before we add the callback. And then similarly, when we're removing listener, what we want to do is if not listeners dot contains key event name. So if that event doesn't exist, we're just going to return out. Otherwise, we're going to grab the that list, and we're going to remove all references of that callback. And then if that list is now doesn't have a length, then we are removing the whole key. Yep, clean it up. All right, now that game has events, how do we use them? Well, when we die, we're going to delete ourselves, and then we are gonna grab game and invoke death. Oh, mono behaviors have invoke. Cool. Let's use a different name. Instead of invoke, we're just gonna send event. So we're not clashing with something else. Okay, send event. Send event. Yes, that's the only one. With a new object array that includes this. Now, where we are listening, elsewheres, so game is going to actually listen to that. So we're going to say on death event. Can we marshal our, I mean, yes, we can, but is it a good idea to marshal our variables out, our parameters out? Let's see. First of all, when we are initializing, first thing we're going to do is we're going to link that up. So we're going to add listener to death, and it's going to be on death event. Method group to action object. So if we added object parameters, it works. But what if we said params? Still works. Well, doesn't make a difference. I don't think it does. Okay. In this case, we want to just do, since we're not marshalling, we're just gonna make sure that we only have one parameter. Oops, dot length. Let's actually gate it. If it's not one, we're just gonna return if dot so the first parameter is, so we're gonna check if it's not, but it is not health, return. Now what this does is it checks if this is health, and then if it is, assign it to the variable health, and then we're negating the whole thing, meaning that if it's not, we're gonna return out. So now that we have the health object, we can do something as simple as if health dot get component player movement, since we know players have that. Try get component player movement. We can now just say out. We don't even need this here, but out player movement. Player movement. So in this case, if we've got player movement, that means we're a player. So we've just killed the player. What we want to do is we don't want to spawn instantly because we want to wait for the old player to destroy. So how do we do that? We want to delay. We basically want to add a list of, I don't know if you can hear the cats outside, but they're doing something they're not supposed to be doing. Spawner trigger time, spawner spawn time, let's say spawn time, and that is going to include a player spawner. So let's just do player spawner for now. and time. And we're going to create a list of spawn time, spawn times. Initialize it when we first create it. And then if spawn times, well, you don't even need to if, we'll just say for each var spawn time in spawn times. So we're just going to iterate through that every time, every frame. And we're going to say if the time of the spawn, you know what, that locks our array, our list, so we can't change it, and we do want to change it. So instead we're going to just do a little trick and start actually from the back. So we're going to say I is spawn times dot count -1. We want to obviously not go to negative indices, and we're going to go backwards. So we're going to grab spawn times I dot time is less than our current time, real time. Is it real time since startup? Or is it fixed time? No. You can do it real time since startup, but time at the beginning of this. The kind of concern with using that is that if we it is a time in seconds. Okay, yeah, we can use fixed time. If you modify the speed of time, like if you scale time, we want to take that into consideration. So fixed time does. Fixed time, you can scale time, and fixed time won't break, or not break, but it'll slow down if you slow down time. So if you want to create like cool, you know, bullet effects or whatever, bullet time. Okay, so in this case, if now the spawner is supposed to spawn, we are gonna take our spawn times I, and we're gonna take the spawner and we are gonna spawn. And then we want to take this spawn, this spawner off the list and clean it up. So now that we know it's player here, we actually don't even need a reference to that. We just right, use an underscore to just throw away that reference. This is a C# thing. So in probably other languages you'll assign it to something and then just ignore that it exists. But in C# it gives you the ability to just discard an out by assigning it to underscore. When it dies, what do you want to do? Well, we want to add it to the spawn list. So we're going to say spawn times dot add, and we are going to do what we did previously, which is add a spawn time object. We're going to add a spawner. So we'll just set it to null for now, but we'll fix that. And we want to take time dot fixed time, so the current time plus a second. So it's actually one second, since it's not an MS. One float second, if we remember that F, and we want to actually get the correct spawner. So we can actually just do this again, which is player spawns, grab all the spawners, and instead of just we're gonna just use the 0 spawner. Cool. Complicated, but we've created a system to link things up. So now we can walk around, and then if we hit H, we're gonna die. Right, you know why we didn't die? Because even though we linked everything up, we didn't add health. Duh. And we need to grab a reference to game. Everything leads back to game. So now when you hit H, we've died. Did we? What happened? Right. You see what we did there? I put it in the wrong thing. We killed the spawner by mistake. Whoops. Move it from there. We actually want to add it to player prefab here. Add health. We want to have 10. Start with 10 health and attach it to game, or give it a reference to game. So now when we spawn, we run around, hit H, we've died, there's no camera, and then we respawn. So when we die, the camera dies too. See, we're here, die, back to 0, 0, 0. We have a game loop, people. So, cool, game loop. Now that we've got that sorted, we've got the game working, basically. It has a flexible connection system between things. We can let's think about what else can we connect. Well, the simplest thing now to kind of look at is, now that we've got a system, is gravity. I mean, it was something we skipped. I decided I didn't want to do jump, only because I think jump is like something that's overdone in first-person shooters. Like every first-person shooter has this like floaty, you know, jump that you can do. But then you look at Metroid Prime, and Metroid Prime, you can't actually jump in Metroid Prime. And then Doom is the same. You can't jump in Doom. You can't jump in Wolfenstein. All these like kind of classic games. So I said, you know, I like that as a design thing. Like I'm just gonna limit jump, but you can still fall, but you can't jump. So if we went back to player movement, player behaviors, player movement, we can do that. So how does falling, how does gravity work? Well, it has two components to it in a game, not in real life. So in real life, there's a force that's dragging you down, which we can easily do this by saying private const vector3 gravity force new vector3. Actually, we can't do can't actually do const, but just because of how C# works. 9.8, right? So gravity at 9.8. So the reason why we can't do this, well, no new, but the reason why we can't do this is because this is an object. So we actually have to do a final. So const is basically the same as a final. Final? Not a final. Well, it's a static, but then what is it? It's not. Is it a final? No. Final is a C++ thing. Well, should actually give us a little hint. Does it? Does it? No, it doesn't. Let me just look it up really quick. Duh. Static read-only. Forgot the read-only. Okay, so that means that once we set this, we can't change it. But it's not like a const is different. Const is a memory thing. Like once the thing is written in memory, it can't be changed. Read-only technically you can change it, but the compiler will yell at you if you try to, and won't let you compile the thing or run it. So it's kind of protecting you from yourself without really like being something that's memory related. But anywho, this is fine. We want to use that, and you see, like here we've got our, if you remember our updates, and we are setting our velocity every frame. And this is like, you set the velocity every frame. So if you stop holding down W, you're instantly gonna stop, like on a dime. It's unrealistic, but that's how games are. If you don't do that, like there's tons of games that have momentum. It feels soft, like it feels sluggish, unresponsive. All the words you hear in reviews sometimes, mushy controls is one that people use a lot. So we are just setting velocity every frame from scratch, but that's not always the case. Like gravity doesn't work that way. It's an acceleration, right? Here, gravity force, so it's an acceleration. We want to increase velocity by that much every frame. So the way you would do that is actually you want to grab your vertical velocity. I've gone back to snake case. Vertical velocity, and the way you do that is character controller actually has a velocity, like it knows how much it moved last frame. And you just want the Y component, because that's the up-down. So this is a float now. And you want to take that vertical velocity, and actually what we can do is, let's actually make this a float, and therefore const, and it's just negative 9.8f. So it's 9.8 meters per second per second. So what does that? How does that work? Well, we're going to take that and we are going to add. Add because this is a negative. So we're going to add the acceleration times delta. So we're going to do gravity force times, again, the delta. So that increases this. We're going to take the velocity, that's the velocity. Then after that, we're going to add the vertical velocity. So vector 3 dot up. Since now we're down is negative, so we're going to take up times vertical velocity. That's I think the fastest way performance-wise to do it. Yeah, and since we're grabbing the vertical velocity every frame from the character controller, we don't need to reset it. And this is like the most basic way of, what's happening? What is going on? Did we go through the earth? Are we? We've fallen down to the bottom of the earth. Cool. It's not every day we do stuff like that. Mesh collider. Why did we go through the... Why did we go through? Okay, well, we can do a couple of things. Let's, just to be safe, set the rotation. Oops, here. So it's already in the right direction. Vertical velocity. We need to multiply this by delta again. That's what happened. And then velocity. So because the jump was big, like the number was already big, we went through the... Yeah, here we go. That weirdness was because we were... I'll show you, but if we walk off, we should actually fall. Yep, there we go. Falling to our death. So the reason why we hopped up in the beginning was because our player spawn points put us slightly in the geo, which pushed us very aggressively up. So maybe if we just pull up a little bit now that we have gravity, 0.6 is too much, maybe 0.3. We should avoid that like weirdness that happened. Yeah, cool. And we have falling. We can fall. Now we want to fall to our death. This is not falling to our death. We can do something where if our transform dot position dot y is less than -1000, we can actually get our health component and damage ourselves for 1000 damage, and that will get us dead. Just the thing, so like players don't get caught falling, falling forever. Ooh, long way. Oops. Yeah, there we go. Just hit 1000. Yeah, that is as we're hitting time, but that we've got kind of a game now. We can fall, we can die, we've got health, and we've got, most importantly, a system that ties everything together. I can't overstate how important that is. Like this part, this thing, like having events and pushing events and pulling events and all that stuff, sending an event and having listeners and all that, super important. Super important. Yeah, and as we do the next couple of sessions, you'll see why. Like it's so much more reliable to just tell the systems that something happened, and then they figure out, like, everything connects itself to everything else, rather than you sitting and manually creating all the connections, either by code or by, like in the UI. And, you create a new map, it's a new level, and you have to recreate all those connections, and then you miss one, and, you've got bugs that are impossible to track down because something happens, doesn't give you a usable error message, and that's a nightmare situation. That's what everyone wants to avoid. And if you do things this way, I'm not saying my way is the right way or anything like that, but if you do things in a way that's organized and allows you to kind of build those links dynamically in this way or in another way, this isn't the only way you can keep things organized, it pays dividends down the line. Like you'll thank yourself when you're 6 months in development and things aren't breaking left or right, and if something does break, well, you've got a good error message and a good way to trace it back. So yeah, it's the secret of M&M as well. Like it's why M&M has been less complicated than normal, than usual. We don't use this exact system. I wish we did, or maybe we will at some point, but we use something that's similar to this, definitely, and you know, it works. You know, over what, a few 100,000 lines of code. You know, and typically that would be a big spaghetti, but it doesn't feel like it. You know, as we're working on it. Especially with like 3 different people, sometimes 4 different people touching the code, it doesn't fall apart, which is great. Anyways, so yeah, that's it for this one. We'll do the next hour soon, and in the next one, you know, since we've got spawning and such, the next one is going to be about giving us you know, a gun, being able to shoot, and then having something to shoot. And hopefully, if we go fast enough, something will shoot you back. And then, you know, that'll be really exciting. Anyways, thanks so much. Catch you on the other side.